Welcome to another video in the series about the TI-ARM Clang compiler. This video explains the elements of the compiler that come from open source. My name is George Mock and I'm your guide. In a previous video, I introduced all these elements of the TI-ARM Clang compiler, and I talked about how there's a color scheme. Some of these boxes are in blue and some boxes are in red. What's going on? Let's talk about that. So the elements in blue are from an open source project called LLVM/Clang, which of course raises a question, well, what's that? So here's the background on the open source LLVM/Clang project. So LLVM is an open source project, and it's really just building blocks of a compiler, okay? It supports many programming languages, including C and C++, but many others as well. Clang is another open source project that's a sub-project of LLVM, and it's the C/C++ front end for the toolchain. Remember in our previous video how I talked about the front end is the piece of the toolchain that issues diagnostics, okay? So that's what we're talking about here. So in common usage, the term Clang refers to both of these projects at once. And if you want some more background on these projects, here's some links you can visit right here. So what are the changes of using the Clang open source elements in the TI-ARM Clang compiler? Well, there's a large investment in Clang from both industry and academia. Here's a few companies you've probably heard of. They've been benefiting from Clang for a long time. Clang is also prevalent throughout academia. It started at the University of Illinois and it's gone on from there to many other universities. Clang supplies a large number of features that can be adapted to TI devices. Okay, this is how TI is picking up support for C++17. We're adopting Clang. There are other features in code coverage. We'll be talking about that later in another video. Static analysis and other really awesome features like that. It's a fast compiler. It doesn't use a lot of memory. We're talking about the amount of memory that you use on the host machine as the build occurs. The diagnostics are very expressive. It makes it easy to understand what's going on when you get a diagnostic. Clang has been used in production ARM compilers from other vendors, including ARM Limited since 2014. A prominent feature of Clang worth mentioning is GCC compatibility. This is something that was baked into Clang from the very beginning, from the first days of that project. And because it's compatibility with all the GCC extensions, it makes it really easy for someone who's got source code that was built with a GCC compiler and some other environment to move from that environment into an environment for an ARM device using TI-ARM Clang, and away you go. These benefits only increase as Clang improves and grows. In fact, TI carefully constructed the compiler infrastructure to make it easy to stay up to date with the changes the open source community makes to Clang. So, whenever you get a TI-ARM Clang release, you receive changes that were implemented by both TI and the open source community only a short time before. And that remains the case with every single release. As this video comes to a close, I'd like to give you two references. The first one is to the home page for the TI-ARM Clang compiler. The address is ti.com/TI-ARM-Clang. This is where you can obtain, this is where you can download the compiler, it's where the manual is available, and other details like that. The second one is e2e.ti.com. This is where you go if you have any sort of question on any TI product, including TI-ARM Clang. And if that question happens to be compiler related, it will be answered by me. Thank you for watching this video in the series about the TI-ARM Clang compiler.